Bismillahirrahmanirrahim and welcome to Rahman Digital Production. This is lecture number 22 of Physics 5054. We are in topic number 4, that is mass, weight and density. At the beginning of this unit, I told you, ladies and gentlemen, that in common life, weight and mass yield the same meaning, while in physics, they are totally different. So, what are the differences between density and mass? Through a table, I want to explain this, that what is mass and what is density. So let us start. We are comparing it side by side. What is weight? Weight is the pull of gravity on the body. Weight is the pull of gravity on the body. While mass is the amount of matter in the body. What is weight? It is a force. What is mass? The quantity of matter, as we discussed in the previous lecture. The second difference between weight and mass is weight has both magnitude and direction. So it means that it is a vector quantity. Weight is always directed towards the center of the earth. So it means that it is having direction as well as magnitude as well. Has only magnitude, that is the size. uh, we are having only the magnitude but no direction in case of the mass. So it is a scalar quantity. It is a scalar quantity. So one is the vector quantity which is having direction, and the second is scalar. Weight is measured in Newton. Yes, the unit of weight is Newton, and the unit of mass is kilogram. The unit of mass is kilogram. Uh, Weight changes from place to place. Yes, if you are on the earth, you will have one weight, and if you are on the moon, you will have another weight. For example, if you are on the equator, you will have one weight, and if you are on the south pole of the earth, you will have another weight. Similarly, if you are on the north pole, you will have another weight. So it means weight is changing time to time. While in the case of mass, mass is constant regardless of the place or location. Mass will remain constant. It means that mass will not change. If you are on the earth or you are on the moon, so everywhere the mass will be the same. There is a very important difference between the two is weight is measured by a spring balance or a compression balance. This is compression balance and this is a spring balance. When you are hanging a weight with it, so it will measure the pull of the earth on this weight. So this is a spring balance and this is a compression balance. When you put a weight, it is compressed and this pointer is moving, telling you the weight of that object, that material. While mass is measured by a beam balance. About the beam balance, we talked in the previous lecture. So mass is measured by a beam balance, while these two balances are used for measurement of weight. Okay, that was the whole story. Hopefully, you have understood that what is the difference between mass and weight. Now we are turning our focus to the measurement of density. We will talk about the measurement of the density, but before that, let me explain what is actually a density is. Density means how much dense that object is. Ladies and gentlemen, when you are performing experiments in the physics laboratory, you are facing and you are dealing different materials such as expanded polystyrene, such as water, such as wood, such as mercury, such as lead, such as iron nails. Ladies and gentlemen, have you ever wondered that why polystyrene is feeling lighter than the pine wood plank, or why, if the volume is the same of both, same volume, but one will feel lighter and the other one is feel heavier. Another example, why if we are putting in a beaker the same volume of water and the same volume of mercury, then why one is lighter and the other is feeling heavier? Lighter and heavier is not the precise definition of an object in physics. We are differentiating and explaining these things with the help of density. What is density? Mass per unit volume, mass per unit volume is called density. Ladies and gentlemen, let me tell you, it is denoted by rho. It is RHO. Rho is a Greek word for R. Is a Greek word for R, and that is used as a notation for the density of material. Let me explain this with another concept. If there are two students, the hair the hair of one student are thicker than the other students. So we are saying the density of the hair of student A is greater than the density of the hair of student B. Density means thickness, thicker. In Urdu, we are calling it ghadapan. For example, if there are uh, milk, there is milk, and we are comparing it with honey. So honey is more thicker than the milk. So we are saying that Honey is denser, yeah, having more density than the milk. So if there is a container in which you are putting some matter, if more matter is there, it means that this is denser. If less matter is there, it means that it is not denser. Ladies and gentlemen, if there is 1 inch of square in which there are few dots, and we are considering these dots as pixel, for example. So if the same 1 inch container is there and there are more atoms are there, so it means that we are saying that this B container is more denser than this A container. So honey in this case is having much more molecules than the water or milk molecules. So that is why we are saying that this is denser. Let me give you another example. If there is a jungle, forest, and there are many trees inside that forest, so we are saying that the forest is much denser. We are using this word very commonly in our daily lives as well, but we don't know the actual meaning of the density. Density means there is thickness, thicker. If more trees are there, the jungle will be more denser. If less trees are there, few trees are there, so it means that the jungle will not be that much denser. Ladies and gentlemen, for substances like gas, liquid, and solids, there is a table given on page number 59. Observe it and see the densities of gases, liquids, and solids. From that table, we can see that 100 kilogram per meter cube, yeah, 1 gram per centimeter cube, and also reason why mercury is much heavier than water. First of all, I want to tell you that the unit of density is kilogram per cubic meter, but before that I am writing that mathematically rho is equal to mass per unit volume. That is the mathematical form: density m divided by v. You know that mass is measured in kilogram and volume is meter cube. So that is why the unit of the SI unit of this uh, density is the SI unit of density is kilogram per meter cube, or gram per centimeter cube is also used in many cases. So these are the two different types of uh, units of, sometime we are using this one, you will see in the question when we are turning our focus to the past paper. So in the past papers, you will see that there are gram per centimeter cube and kilogram per centimeter cube. This gram centimeter cube it's sometimes written as -3, and this kilogram meter cube per meter cube is written as -3. Both of them are the same. How if we are writing gram centimeter cube, so there is plus 3, but when it is going upward, so gram centimeter -3. Ladies and gentlemen, keep one thing in mind, that it is my experience that most of the people are writing like this as well, -3, because they are seeing in the literature that centimeter is always -3. So beneath in the denominator portion they are also writing -3, but this -3 is not correct. If it is in denominator, then it is Cm plus 3. Let me tell you that why they are confusing you. There is one reason, because I am also having a knowledge of computer. When they are typing this in the computer, you need for this equation editor to write it in this form. So when you are writing it like this centimeter, this is in one line. But if you are writing in this, because this is in one line, but there are division symbol and these sort of things, so it is very difficult to, it will take time, and if it is repeating again and again, then it will do what, waste your time. So that is why they are writing gram centimeter minus cube, because control plus equal is for that superscript. So writing that superscript is comparatively easy as compared to this in equation editor. That is a trick I wanted to tell you, because I faced when I was writing my books. So I faced a lot of difficulties in this, and then we are writing it like this. So both are the same. For simplicity and to save the time, they are writing it like this, but you have to be very careful. Okay, I told you that there is a table given on page number 59. On page number 59, if you observe it, so we will see that why polystyrene is looking lighter. Yeah, the density of expanded polystyrene is less than the same amount of pine wood. In the table you can observe that 1 centimeter cube of expanded polystyrene is equal to 0.016 gram. While if we are seeing from the table, for pine wood, mass of 1 centimeter, the density I should say of this 1 centimeter cube, yeah, if you are writing mass, then you have to remove this per gram, because that is the unit of density then. So 1 centimeter cube is equal to 0.50 gram. Ladies and gentlemen, 0.50 gram and 0.01 gram, if we are taking in percentages, then uh, The density of pine wood is 30 times heavier than the density of expanded polystyrene. Ladies and gentlemen, similarly, in that you can observe in that table that why there is a difference of thickness and uh, thickness between the mercury and water as well. If the same volume is given in a beaker, then we will say that mercury is more denser than the water. Ladies and gentlemen, let me tell you that mercury is the only metal which is behaving sometime like a solid and sometime it is behaving as a liquid. Both the properties are there inside this uh, mercury. So we can call it as a liquid as well as sometime we are calling it as a solid. Both the properties of mercury are there. One thing more, when I was doing the Cambridge International examination training, then the trainer told us that there is a thermometer in which we are using mercury. But if sometime the thermometer is falling down and it breaks up, breaking up, then you don't have to touch the mercury because that can provide a severe damage to your skin. The trainer told us that in England we are having different teams, we are calling them, and they are coming to clear that uh, mercury. So, whenever you are dealing with the mercury, ladies and gentlemen, you have to be very careful. Don't touch it. Many people are putting it, this is my observation, that many people are putting that mercury on the hand, so it is running there and here. Uh, so they are enjoying it, but whenever you are not understanding the damages of a metal, then don't touch it in the laboratory. That is one precaution you should take. Similar case is with the, if there is radioactive element inside your laboratory. When I was in the university, they told us not to open the lid of that box in which there was uranium. Uranium is a radioactive element. So, radioactivity, if you are exposing yourself to the radioactive element directly, they are causing cancer and other diseases of the skin. So, ladies and gentlemen, be careful while you are working in the laboratories. Many things are dangerous for our health if you are performing the experiment of electricity. So don't touch a wire which is nagged, or don't touch the uh, wire which is positive and negative, so it will produce damage and possible death as well. Be careful in these things, I wanted to tell you. Okay, ladies and gentlemen, let us do one question, and that is example given on page number 60, and that is example 4.2. A block of concrete 4 meter long, 0.4 meter long. So I am doing work example to clear our concept of the how practically we are using. There is a block that is 4.2. There is a block of wood or whatever. There is a block whose length is 0.4 meter, 0.4 meter. Its breadth is 0.3 meter, 0.3 meter. So it is a cuboid, not cube. Uh, and the height is 0.1 meter. This is given to us, and they are saying that it is having a density of 2500 kilogram per meter. So I am writing rho for simplicity, kilogram per meter cube. This data is given, ladies and gentlemen, is rho is equal to mass per unit volume. So in this case, uh, we are finding the uh, mass per unit volume, and they want us calculate its mass. So I am giving equation number A to it, and we need volume. Sometimes the value is not directly given to you, but you can find because the data is there. As volume is equal to length into breadth into height. So I am putting 0.4 multiplied by 0.3 multiplied by 0.1. So when we multiply it 0.012 meter cube. Now volume is this, and the density is also given to us. So M is equal to density into V. So density is 2500, and volume we found it 0.012. So it will be kilogram. They calculated it inside this, so it is 30 kilogram. 30 kilogram is the answer. That's it, ladies and gentlemen, for today. Thanks for your patience. Uh, Tomorrow we welcome with the new concept. Thank you very much, and Allah Hafiz.